I'm very pleased to have Rachael Levy here with us. I will let her say a few words about herself and get started.
Great. Thanks so much, David, for inviting me, and thanks to you all for showing up. Is the volume okay? Can you hear me okay? Great, thanks. I'm just delighted to be here. I'm going to share screen in a minute, but I just wanted to take a minute to get to know you. You might already know each other. I don't know. So thumbs up if you feel like you already know each other. Thumbs down if you don't really know each other, those of you on the screen, just so I know. I see thumbs up, thumbs up. Any others? Thumbs up. Any thumbs in the middle? Like I know some people, thumbs down, some people don't know people. Okay. So just to tell you the tiniest bit about myself, I've taught all the way from 5th grade up through graduate school, and the kind of math that I'm talking to you about today is something I've done with learners all the way from kindergarten up through the workplace. And we're really talking today about the math that you do. Like once you go into the workplace, this is what we would call applied mathematics. It doesn't matter whether you're a pure mathematician or an applied mathematician. Once you go to work, it's all applied math because you're doing it in the context of a job or in the context of your life. And currently I'm in something called the Congressional Fellowship, working in the government. But before I've worked at a college, I've worked at a high school, I've worked at a middle school, and I work with a group of teachers in California that I've been working with for about 7 years. And so I'm hoping maybe at some point in the future, we could have a session where you could meet them and hear about some of the things they've done in their classrooms all the way from K up through 6 with math modeling. So what I'd love to start with is just if you could tell me 3 things about yourself. One is your name, and one is who you teach, and the third is what your students need from mathematics. So,
may I interject? Or we actually generally do our introductions and have people talk about themselves. We have a 20-minute block after your math.
Oh, so should we just launch into the math? Well, maybe you could do this. It will help me actually just to know what levels people teach. So maybe you could.
So if we do the introductions now, we'll have less time for the introductions later. And
why don't we just have people put this in the chat? So if you could put in the chat your name, then you can all do it simultaneously. Who you teach and what you need, what your students need from mathematics, because that's going to motivate everything that we do right now. So I'm just going to look at the chat as you're typing things in. Great, so it's 8th grade.
I'll make one comment that if you put things line by line, we might get people scrambled. Like Karen just put her name and her grade. She didn't put what she wanted her teachers. So then Alan put, if Karen types in later, it'll be mixed. So if you type it all in one thing like Alan did, that'll be easier to see who's.
That's great. And I'll just give a couple more minutes for people to do that. While you're doing that, I'm going to start my slides. Great, and I see some middle school, I see some high school, I see, well, so far I mostly see middle, oh yeah, I see some high school, that's great. And what I planned today was really for any level, all the way from elementary up through high school, even though I knew you all would be leaning towards the upper grades. And then I'm gonna try to ask, let's see if I can get, so I'm just seeing my screen share and I'm trying to remember how to get to be able to see you all in addition to my screen share. So I'm trying to get Zoom to show me you all too.
In the upper part that says view options, and under view options, if you do something.
That's what I'm looking for, but I'm not getting my usual, you know, when your system upgrades, everything gets different. So let's see if I can see. Show See if that works. Okay, yep, got it. Great. Okay, so what I'm seeing is that your students need engaging real life applications. They need to enjoy learning mathematics. And so that's absolutely what we're going to talk about today. So before we started, I also wanted to thank Anna for talking with me for about an hour before this presentation, because I just really wanted to hear about your classrooms and your students and what life has been like for you in the last year. So I do have that context, and I've traveled in your area before, but right now I'm in North Carolina, so I'm really far away right now. Okay, so let's move on. So I wanted to just talk for a minute about where you can go to get some further information about what we're going to talk about today. I don't know if any of you have seen this report. This is called the Guidelines for Assessment in Mathematical Modeling Instruction, and it's free online. So you'll have these slides and you'll have this link. This is basically a guide to teaching math modeling or real world applications all the way from kindergarten up through undergraduates. It also has rubrics for evaluating mathematical modeling. Lots of, the way we wrote it was to try to imagine that you were sort of sitting over the shoulder of a teacher or a student looking at what was going on. And so, all of the things that I share with you today will be from different people who worked on this game report. And the game report talks about what we're going to do today. Mathematical modeling is a process that's used to make sense of the real world. One of the things I really care about modeling is that this idea of choosing and using math tools. So I want you to think for a minute about when you were a student of mathematics, how often did you actually have a real choice about which tools you were going to use? I know that with the math circle problems, they're often open-ended or open beginning, open middle, open end, and they have a lot of choice. But at least my experience with textbooks was often if you were on page 11 told you which process you were going to use, and then you'd use that process repeatedly because you were practicing it. Did anybody have an experience in mathematics as a student where they were like, use whatever math tool you want as long as it makes some sense? I'm gonna look and see in the chat and see if anybody has any examples of that from their own experiences, because maybe you do. I'm looking at your faces. I'm seeing some head shaking, no. Can you think, I mean, I think this is amazing because imagine even in, let's make some connections with art. Like in an art class, there's kind of times that it's the day you use paint, but often you still get to choose your colors or to mix them somehow. Or if you have crayons, you get to pick which crayon. Or if you're drawing trees, you get to decide what kind of trees. But in mathematics, I think students' experience of mathematics is often that they have zero choices, and furthermore they have this feeling that if they make the wrong choice they'll get the wrong answer, right? That they'll be wrong. And so I feel like at least my experience of mathematics involved, even though I felt welcome in the mathematics world, I still felt like there was always this danger of being wrong and a big risk to take anytime you put answers on a paper. And then if they were wrong, they got a big red X on them. And I never experienced that in an art class where I drew a tree and somebody put a red X on it and said, your tree is wrong, right? They would say, is that really a tree? That doesn't really, tell me how that's a tree. So I think part of what we can think about as we're doing mathematics with our students is, can we respond to their work a little bit more like this is their creation? And we don't want necessarily to say something looks like a tree to us when it doesn't, but we could also ask them how it looks like a tree to them and then get more insight into their thinking. So I really want to think a little bit about how educators can provide these opportunities and ask the question, how early could we start doing this with our students that mathematics is more open-ended and more connected to the world? So I would love to pose as a long-term goal that your students eventually form a team or teams to participate in a national challenge called the Mathworks Math Modeling Challenge. And what this is each year for high school students, there's a big messy problem posed, and teams of students work for, I think, 36 hours on it or some amount of hours on it. And then they turn in their answer and they get feedback on their answer. for mathematicians. So this year's challenge was defeating the digital divide, internet cost, needs, and optimal planning. And online, you can find all of the questions from over a decade of these challenges. You can find examples of how to work with students, student work, what the judges thought of the different kinds of answers. You can see student testimonials about how meaningful this was to them. And having served as a judge, I've seen students write answers that totally depend just on arithmetic. We always try to pose these problems so that a student could solve them just with arithmetic, but I've also seen them use algebra, statistics, programming, calculus, differential equations. So these are also problems that you could solve with as high a level of math as you want. So they're supposed to be very low floor, high ceiling. And so I've seen students say, I did terrible. I know I did terrible, but this was really fun and I want to do it again next year. So the success of these kinds of problems are that students can get started on them. They're allowed to use any internet resource, any data they want, any approach that they want. And the key is that they have to communicate their answer and justify it. So I won't give you a lot of detail about this year's problem, but I'm sure you can relate to the issue. You know, at my daughter's house, which is only 10 miles outside of a large, you know, a town with a large university, we get no internet access. We can't use our cell phones. We can't get internet access. And that's not even very rural. And so I'm sure you can relate to the idea that the digital divide is huge and that it's not entirely obvious what the best solutions are. So this is really saying, how do you ensure that everyone, even in rural and low-income areas, has sufficient access to high-speed internet, and make a model that makes a suggestion how to access the internet. Should it be cable? Should there be more fiber optic lines? Where should they be? Should there be satellites, mobile broadband? If there's going to be investment, which we can see that there is being some investment right now, how do we make sure that this investment is equitable and that it really achieves what it's supposed to achieve? So that was a great problem for this year, but you can also see other problems on all kinds of topics like converting trucks to more renewable sources of energy, or composing school lunches that are nutritious, but that kids will actually eat and that are affordable, or even things like what would happen if two-year college becomes free? Like, what would that happen in terms of affordability of college? And some of these things are really on the table right now. So it's an especially interesting time to look back at some of these old problems. But maybe a short-term goal, if the long-term goal is you eventually have high school students doing these problems, a short-term goal might just be that every student that you have in your class, when they walk out of their classroom, they recognize math all around them in the world. And I'm sure this is something that some of your students already do. I'm sure this is nothing totally revolutionary, but I think it's an exciting way to think about math. So I just wanted to share with you a little bit what I did with a teacher who is a brilliant kindergarten teacher. And this work is actually going to appear in a book soon. Robin Stankiewicz van der Zanden did this work with her kindergarten class. And she posed a problem that Mr. Pete, which is the name of her husband, so the kids knew who Mr. Pete was, will be buying cupcakes for Faith's birthday, and Faith is her kid, so they knew who Faith was. And she said, there's going to be 2 adults, 2 big kids, and 2 little kids. The cupcakes have regular size with chocolate frosting. So how many cupcakes should he buy? And one of the cool things about this work is that rather than just having the kids write their answer, she recorded their voices using a free program called Seesaw, so that with kindergartners, often they don't have the symbols to describe what they want, but they can tell you what they're thinking easier than they can write it down. And you can, as you do this, you can think about what choices the students were able to make. So can you suggest, if you were solving this problem, what are some of the genuine choices that you could make? I'm going to look in the chat. I'm going to wait till I have 3 ideas in the chat of something you could choose to solve this problem. So one person said you could choose to ask how many people there are or how many cupcakes you're going to give each person. So there are, there's 2 adults, 2 big kids and 2 little kids, but are there more people than that? Are these the only people showing up? And then how many cupcakes is each? Is there anything else? You could have a diagram with each person and maybe it could show how many cupcakes they would eat. Yeah, one more idea. When you go to the store to buy cupcakes, what do you get to choose? Or if you bake cupcakes. I usually made brownies rather than cupcakes for my kids. All right, I'll give you a hint. The kids asked how big the cupcakes were. And I thought this was a really brilliant question because, I'll put this in it. How big are the cupcakes? Because the kids, these are kindergartners, right? And they were like, well, if the cupcakes are really big, you can chop them. And if they're small, you're going to need more. And this is proportional reasoning, which is something we really have trouble getting our middle schoolers to talk about, right? But the kindergartners had this mathematical thinking already. They also ask things like, do you like cupcakes? Or, if they're older, sometimes they'll say, can you have gluten? Are you allergic to anything in a cupcake? Are you allowed to have cupcakes? So these kindergartners, it was interesting to us how many different questions they were able to ask about these problems that really tie to questions that come up in industry, which is if you want to decide what products to sell in a store, or if you're in the tourism industry and you want to decide what kinds of opportunities to offer for your tourists, you really have to think about what's the market out there and what are the things you should be taking into consideration in order to have a collection of products that are going to work. And these decisions, like, are you going to sell, giant cookies that you can divide up, or are you going to sell big pizzas or small pizzas? What are you going to sell in your store, or what kinds of, are you going to have long tours or small tours? Are the tours going to have lots of people on them? Are they just going to have a small number of people on them? These are all considerations in businesses. And I felt like these kindergartners, because we hadn't yet told them what a math problem was supposed to be like, they were much more open-minded about all the different things that you might want to take into consideration in this problem. And I feel like sometimes by the time they're in 5th grade, they're more narrow-minded about what it is to do math and what problems should look like. So this was really interesting for us to think about. So here's an answer from one kid that explained 2 cupcakes are for Mr. Pete, 2 are for the big kids, and 2 are for the little kids. And then they put an extra 2 for the moms. So they actually answered the question a little differently than it was asked. And then notice that where it says name, they put 8, because this is not a reader yet. So we have a child that can count 8, that can write 8, but they didn't recognize that the word name was where they were supposed to put their name. This class had a lot of English language learners in it. This was one of them. And so it was really wonderful to see how much mathematics that they could demonstrate between their voice, explaining things. We wouldn't know what those cupcakes were for unless they were able to use their voice to give us more information. And sometimes I think about this even at the high school level, like how much are kids able to think and describe that they have much more trouble putting down in symbols or putting down on their papers. And even at the college level. So here's another response from a student where they said the little kids, and they drew pictures again, and I noticed you said pictures, get 1 cupcake each. The big kids get 2 cupcakes each, and the grown-ups get 3 cupcakes each, which is really, again, this proportional reasoning that we really wish middle schoolers would think about more. And here we're seeing it in a kindergarten picture. And if we could encourage this and think about how to build these skills when they're little, this literacy that they already are coming in with wouldn't sort of get removed from the math context. Because again, this is really great thinking of the sort that you would do in a business where you would think different categories of customers would require different kinds of amounts. And then this kid did total up the cupcakes and said there should be 7. And they decided that each person at the party should only get 1 cupcake. So then they circled, because with Seesaw, they could also use a pen in their iPad and circle in real time. So they circled like 2 for the little kids and 2 for the big kids and 2 for the grown-ups, but that's only 6. And so they said, you really need 7 because if you have a party, Auntie is going to show up, whether you invited her or not. And I really love this too, because again, they're bringing in the context from their own home environment where they're like, you have a party, you better count for Auntie. And when we did this with 5th and 6th and graders and high school students, if you say there are going to be 6 people at the party, they're like, then there need to be 6 plates and 6 chairs. And if you say, well, maybe more people will show up, they'll say, no, the math problem said 6. You have to have 6, right? Whereas in real life in a business, you always have to think about, right? What are you going to do if extra people show up? What are you going to do if nobody shows up? And so again, these kindergarteners have some of this mathematical modeling, sophisticated reasoning, bringing in their own knowledge of the situation and context from their own community to the problem. And they all had different answers and different justifications, and all of that could be validated. So again, you didn't have to have that red X on the problem that was like, nope, the answer was 6. All of these answers were wonderful and things that the class could grow off. And so after they would have communication about this and they would share their answers, the kids said, hey, we're getting smart. And what I really love about this is that I think a lot of times math is thought of as a really individual sport and I'm smarter than you. And this kindergarten class had built this community of learners where they were like, it was a we feeling. We are getting smart, right? And it wasn't just about who was the best or who had the best answer, but they could really see that each of them there was room for their individual thinking, for their reasoning. And so that collectively they were feeling smarter, which again is wonderful for a classroom community. So I'm just going to pause there to see if anyone has any questions. Feel free to ask them in the chat or out loud about this. And I only raise this knowing that you all are not teaching kindergarten, you're teaching middle and high school, because for me as a college professor, it was very inspiring for me to think about my own practices with my own students and how I could give them opportunities to be more creative and to have more ownership of their work. And I really did transform some of the things I was doing in my own class, how I had them giving them opportunities to explain themselves or to be more individual than I ever had before, even in courses that I didn't think I had the time to do it. So let me stop for a minute, see if there's any questions or comments. Al said, I love that they remembered the moms. And another person talked about, Elisa talked about restricted time and standards to cover, really cut down on discussion time. Absolutely. And I think this is something we have to reckon with as a profession, because what we saw with these kinds of problems is that because there was a context and because the kids had the ownership of the problem, they would refer back to previous problems. Every time they got a new problem, they could lean on the information from the previous problem because it was more memorable to them. And I feel like so much in mathematics, every time we go to a new unit, it's like we never did anything before. It doesn't connect. And certainly the kids aren't usually making their own connections, but these kids would say, oh, remember in the zoo problem, we said blah, blah, blah. So maybe in this problem, we should also be taking that into consideration. Or, well, we added them up that time, so let's add them up. Or we chopped them, so let's chop them these times. And again, that's kindergarten, but at any level, you really would hope that as you build your mathematical content, that students are making comparisons. Okay, we're doing quadratics now. How are they different from lines? How are they the same as lines, right? How do you get a quadratic function from 2 linear functions? You know, what if you put 3 linear functions together and multiply them? What would you get then? Like, how are all of these things interconnected so that it doesn't just feel like you have a brain full of these things that don't have any relationship with each other? So again, I really want students, we reteach so much in school. We spend so much time reteaching, right? And so if we could teach mathematics in a way that it sticks, because there's a common context that will move things from short-term memory to long-term memory, I think we'll get that time back because we won't constantly be reteaching. Any other thoughts before I move on? Okay. All right. So I'm going to give you a couple of thoughts and then we're going to move to an activity. So I just wanted to say that these problems aren't just open-ended. We often talk about open-ended problems like, I'm going to give you all the same problem and then you're going to get different answers. They're actually open from the very beginning, because as you saw, some of the students redefined the problem from what if I have 6 people plus auntie, which is really a different question. It's related to the original question, but their strategy from the very beginning was their own. So these are open at the beginning because you can define the problem, in the middle as you choose your strategy, and at the end as you communicate your solution. And these are really things that employers want. Employers really complain that students come, even if they've had calculus or linear algebra or differential equations or fancy mathematics, they have no clue where it shows up in their work context. And so we don't just want students that can do things with math. We want students that in a totally new context can say, I know which math tool to pull out of my pocket, and I know how to use it, or at least how to try to use it. And I know when this tool is not working well, and I need to reach for a different tool. So these are some of the things that I've heard from employers. And I gave you a website at the bottom where you can see some descriptions of people at Big Math Network who are talking about how they use math in their jobs, all different kinds of jobs. All right, so I'm just going to play an example of something that has been a fun game for me. I'll go into a business and just say, what's your biggest problem? And see if I can figure out a problem that students could help solve. So this was a hotel that I was at in Montana, and it had just opened. And these 2 people at the front counter said, why are you here? And I said, I'm here to work with teachers on math modeling. And they said, oh, we don't like math. We've heard there's this new Common Core thing. We don't even know what it is. We don't like math. We don't do math. We're sorry. That's scary. And I said, oh, well, what's your biggest problem? And this was and they started to talk, and I said, stop, can I video you explaining what your biggest problem is? So they're like, sure. Okay, so this is the moment, and it's going to be a little loud. So if you have your volume up really loud, it's going to be a little loud when I start it. Okay, this is what these are not students, these are adults at work.
Wait, no, what did you just say?
I said that the carafes hold 10 mugs per carafe. So.
Oh, okay, so maybe we need to go over here and look at the carafe.
Right. Well, and the other problem is that a lot of people use these takeout cups, and we haven't figured that out. And I think there's 2 mugs to every takeout cup. So we have a mixture of mugs and cups, and it's just
The mugs are bigger or the cups are bigger?
The cups are bigger.
The cups are bigger. Oh, okay, can you show me your coffee cart?
And then some people come in here with their own mug, those travel mugs, and the next thing you know, this thing's empty. And so we've miscalculated.
Awesome. Oh, so coffee is a
They put in it too, because
yes, it does. It absolutely does. Thank you.
Okay, so that woman, the one that's talking, is the one that said, I never do math. And all of a sudden she's using all this language like, this one's twice as big as that one. And, we need to calculate, and I miscalculated, and this is a hard problem. And you better take into account the cream, because the cream needs to be in the cup. And, we never know when to fill up the coffee carafe. And this is our biggest problem, because if we don't have coffee for our patrons, they're grouchy, and then they have a bad impression of the whole place. This is the most important question, is like, how much coffee to make, how to make sure that carafe is never empty. And I said, oh, well, what if I brought some students to solve this problem for you and work on this problem for you? And they were like, well, only if we get to help. And so what I just want to emphasize is that in like 10 minutes, these adults who had a totally negative perception of mathematics, relationship with mathematics, went like from 0 to 60 in talking about quantifying their most difficult problem. And all I asked was one question, which was, what's your biggest problem? And they went to town. 0 other prompting. I mean, I was trying to check in or out of the hotel. I can't remember. Like, I just walked up to the counter. And this is very common. So I have just video after video of people talking about math where they start out saying, I don't do math, I don't even like math. I was always bad at math. And if you just ask them to talk about math in the context that they understand, they very quickly can, even if they can't tell you a solution for a problem, they can describe all the elements of a problem that need to go into a mathematical problem solving session. So we just need to take them the next step to realize that they have the mathematical tools in their pocket to solve problems like this, to solve the hardest problems that our society faces. So now we have about an hour left to play a little with math modeling. So the first thing I wanted to do was to think about what it would be like to just get your students going down this road. Now, some of you may be really far down this road already, but even so, these might be useful for warm-ups for your students. So you can play a game. Again, we talked a little bit about, Elisa brought up this issue of time, which is a real issue. I'm not going to trivialize the issue of pacing and testing and the need to attend to certain things in your course. Ideally, they will come up in a way that your students will remember them. So I think our job as teachers is to do these open things and then recognize the opportunities to say, okay, now let's talk about quadratics. Now let's talk about linear functions. Now let's talk about exponentials. Now let's talk about proportional reasoning. So we have to know our standards. We have to know our goals so that as students are coming up with these solutions, we can guide them to explore, well, what if you tried this? Have you tried this kind of function? Have you tried this kind of approach? Have you tried using, for little kids, have you tried using multiplication instead of just repeated addition? These just always, they will tend to lean for what they're comfortable with, but then helping move them to try some more recent things. So if I were going to ask you what your students care about, can you put some things in the chat? What do your students care about? Or you could say, what are their biggest problems? I'd like everybody to try to say one thing, either something they know is a problem for their students or something that they care about. I'm going to wait for a little bit because it might take time for you to think of something.
Can you clear your chat box? It blocks the PowerPoint screen.
Oh, thank you for saying that. I'm so sorry. I didn't realize that. Yes. Thank you. Whoever said that, I appreciate it very much. So I will put it over here. It will cover up your faces, which will make me sad, but I'll still be able to see if you're typing anything. And if you prefer to just unmute and say something rather than type, that's great too. But I'm going to wait a little bit. Okay, so I see video games, anime, sleep. Basketball court. Art. Video games, drawing, horses, motorcycles. They care about math that they can use, friends and family, food. My students, I remember asking my high school boy students, I had a class full of boys at one point, and I asked them, what would you do for a hamburger? And they were like, anything. And I was like, well, what wouldn't you do for a hamburger? And they were like, there is nothing we wouldn't do for a free hamburger. That was just where they were at. It was illuminating. Yeah, they'd like to be able to remember things more easily. So they might be interested in memory, how memory works, or how to remember things better. Hot Cheetos. Yeah. So any of those could be context. Pizza for a problem. Ramen. Yes, yummy. Now you're making me hungry. So let's take horses, for example, for a minute. So okay, I'm going to do something one should never do and grab a picture of a horse in real time. Let's see. Okay, here's a picture of a horse. Apparently, this is an ad for equine digestive supplements, but okay. Are you seeing my whole screen or just the,
It's you've got it covered. So whatever's showing, we just see a gray rectangle.
oh, that's terrible. No, thank you, Zoom. Okay, I'm going to grab something.
I think you have to share that screen.
Yeah, I'm just going to grab it and put it in my slides. Okay. I'll close that out because that's not going to help you. All right, so here should be, hopefully, yeah, here's a picture of a horse. So say we were playing Where's the Math with this picture. What could you notice about this picture? What could you wonder about this picture? And what kinds of mathematical questions could you answer about this picture? So I'm looking in the chat. Because remember, I think the idea is here to have the students walk out of their door and see math. And if they see a horse, if they have a horse or they see a horse, the question is, does that just look like a horse to them or does it look like some math? And the goal is that it starts looking like some math to them, not just a horse. So what kinds of things could you ask about a horse that has, oh, you don't see a picture? How interesting. So can you see the picture in the, thank you, David. Can you see this picture that I just highlighted here? I see some nods, so some people can see it. Okay, well, I'm going to describe it to you. So imagine that you couldn't see it all. I should still ask the question. So this is a picture. I'm going to describe it. There are two horses in a pasture. I would say there's some hills or mountains in the background, and they seem to both be eating grass. And the grass seems greenish, but I would say it's not very tall grass. It actually looks cropped or mowed. It doesn't look to me like a field of grass that's been growing for a long time. It looks like pretty low, maybe even mowed grass. All right, so now I'm seeing some questions here in the chat. So I'm going to scroll up. All right, I notice horses eating grass. I wonder how much grass they eat. Yeah. So if I had a student say, how much grass do they eat? That's a great place to start. So how much grass do they eat? But then you could say, well, let me ask you back, Anna, how much time are you interested in, like eat how much, over how much time are you interested in? What do you think, Anna? Can you type how long you want to know? So Anna's interested in how much the horses eat in one day. So what I was saying about knowing your standards is if someone says to me, I want to know how much a horse eats, I'm thinking in my mind, it's easy for students to think about quantities and it's really hard for them to think about rates. And so I'm always going to want students to start thinking about rates so that they're using that better. That's going to help them in chemistry. It's going to help them in physics. It's going to help them in mathematics. It's going to help them in life. So, you know, when you eventually get to things like interest rates. So if Anna says, I'm curious about how much the horse eats, I'm going to say, eats in how long? And then she's going to say, eats in a day. And I'm going to say, oh, you want to know how much the horse eats per day. So now you've got a rate, right? Amount the horse ate in a day. And again, I don't care that it's a horse. I don't care that it's grass, but maybe Anna cares about horses and cares that it's grass, right? And we've got, and I, you know, I don't care whether she says a day, a month, a year, a lifetime, any of those answers, but then it becomes Anna's question. Anna's asking, how much does the grass eat? And now Anna's asking, how much does the grass eat in a day? And you can see really quickly that then you can ask the other questions about the eating behavior, like how much does a horse have to eat before it gets sick, right? What mixtures of things? If you want to talk about fractions, what mixture, right? What is a horse diet? What should a horse diet consist of? Like what combination of things, right? What's the nutrition that's going on for a horse in grass? Why is grass good for a horse to eat? Now you're getting into chemistry, you're getting into biology, you're getting into veterinary medicine. So you're connecting a question that might come up in a math class where you're asking the question, how much can a horse eat in a day? Not only to start seeing math in their horse, but then also to say, if I think about the math of a horse, now this is going to connect me to other subjects that I study in school, like physics, like, you know, does a horse run faster if they eat more grass, or do they get a belly ache and they run slower? Like, I don't know. Now you've got another rate. And so there's so many things. So I hope you're sort of getting the gist of what I'm saying is you can start with any picture, try to get people to ask questions, but then you need to know your standards. You need to know what the mathematical targets are, right? And then you need to somehow connect that exploration of the horse to whatever it is, you know, whatever it is, kinds of things, you know, your students need to explore more, that they need to struggle with, that they need to try to understand. So how much does it cost to own a horse? How much does it cost to own 2 horses, right? Is there any, I mean, that's a really interesting question, because is there any, does it scale? Like, is it cheaper per horse to own 10 horses than it is to just own 1 horse, right? How much does it cost per horse if you have 10 horses versus 1 horse? Because if you build, or if I build a barn for 2 horses, is that, you know, better than 1? Or the amount of grass, or the veterinary bills, or the medicine, like, can I buy medicine in bulk? Can I buy food in bulk? And so things get cheaper. These are all really great things for kids to know, both if they're running a business or in their lives. Things about measurement. So how far away are the hills? How, right? How are those horses the same size, or are they not? Now you get to things like image processing and perspective in a picture, and estimation, and those kinds of things. Let's see, how many square units of grass area can this horse cover to consume? Yeah, so if you wanted, so my daughter has a pig actually, and she uses this pig to till her garden. So the pig, so if there's an interesting question, like her question was like, how much land should I let this pig till up to make gardens before I put it in the woods where it's not going to be like, so that I can still mow some of the areas that I have, right? And so the issue of how to feed this pig, how much scraps to feed this pig versus food that comes from the store, you know, how often to refill the pig's water so that she's not doing that constantly. These things all came up for her as well. And so again, each student could pick an animal and ask different questions because they care differently. Marty mentioned scale drawing and dilation. Absolutely. So there was a really cool task that one of our teachers did, where the students were imagining what to do with a vacant lot across from their school, and they were going to make a proposal to the city because it was just empty. And they were creating a drawing. They eventually decided that this should be a family-owned restaurant, so they were creating drawings. And the teacher gave them 2 kinds of graph paper. They gave them the ones with the tiny little squares and the kind with the big squares. And the way she posed the problem, it was actually easier if you picked the graph paper with the tiny squares, because you didn't have to say that each square stood for 5 of something. Each square could just be 1 of something. But the kids thought the big paper was easier, so they all picked the big graph paper squares, and then they actually had a harder problem because they had to do the scaling. So that was very cool. So that was, again, a cool opportunity where she gave them a choice of tools, and they were drawn to the tool that they thought would be easier, but actually mathematically made things more complicated. Very cool. So thank you for all of those thoughts. So this is a game you can play with your class. You can play it for 5 minutes. You can play it for 5 hours, right? This could become a whole unit that you pursue. And again, it's your decision as a teacher how to use your time, what's worthwhile, whether this is really catching on for the students, whether they're getting into it, and whether this is serving the purposes of the kinds of experiences that you need for your students to have. Any thoughts or questions about playing Where's the Math with your students, or what's your biggest problem? Could you give me a sense of whether you think that is something you could do with your students? Could you just give a response thumbs up or if you think there's a reason that this would not work with your students? I would really love to hear about it.
I think it would work well with my students. Is beginning with a topic that just really excited them. And then as you moved throughout the year, you could bring in different topics that maybe they aren't even interested in, but could wrap their minds around.
Yeah, and maybe even connect with a teacher from another class. Like one of our teachers, they were reading Tuck Everlasting, which is a book in their other class. So they started creating all these questions that they could ask about the characters and the story of the book that they were reading that were like, you know, how big is a drop of water, for example, or those kinds of things. And so there were some mathematical questions that came out of their history or out of their science. And so again, you know, if you can connect to other subjects and cooperate, for me, one of the biggest sad things that happens when you go from elementary to middle school is that because, well, I don't know how it is in your schools, but in a lot of schools, your math teacher is only your math teacher. Your math teacher isn't also your science teacher like it is in elementary. And there's so many fewer opportunities for that cross-disciplinary connection because you're sort of in your silo. And so again, you know, if you could pair up with the history teacher or the arts teacher or the music teacher to ask some mathematical questions about a song that they're singing in chorus, or, you know, whatever it is that they are interested in or doing in another course. But I feel like that also is another way of saying math doesn't just live in this, you know, once you get out in the world, math is part of everything. Thanks, Elisa.
Ray, may I show something that may help is teachers use this? Show a couple
Yes, and then Marty had a comment as well.
I'll let Marty comment and I'll take the screen share.
Okay.
One of the things that I do to have students learn about the math around them is they do a postcard. They draw a picture of whatever they want to draw, and then in the back, write to someone about what the math connection is. So some of the students drew like skateboarding, and so they did measurements for the speed. And then I saw hogans being drawn. That's the geometry connections. And there was one where there was a tree, and I said, and that one I love because it was so creative. And she connected the tree to how many branches, how many leaves could be on that tree. So there was a lot of different types of postcards that the students drew, and it was just about what they enjoyed in life and making that connection with the math and in real world application.
Thanks, Marty. That's so great. And I can think of so many ways to take that tree example towards some of the standards that you're always trying to think about. So, any other experiences from classes before David shares something as well? Any concerns about doing this with your class? I mean, I think it's risky in real time to do a Google search for images because you get things that you don't want to see. So again, you want to make sure that you do it carefully in a way that you're only bringing things into a classroom that are appropriate. But any other thoughts or ideas? Oh, Priscilla, yeah, were you going to say something? You can unmute.
Yeah. I have to get off video because my Zoom is glitching. So, but I think the sound will be okay.
Okay.
So I work with Kayenta Unified School District, and one of the things that worries me as a sixth grade teacher is the students are very apprehensive. They are like, they don't want to tackle any problem, and they just wait and wait and wait, and that just like, come on, you guys, you know this. I was a second grade teacher for 14 years and 4 years fourth grade teacher, so I kind of break it back down like what you're doing. It's reintroducing math in a way where it's doable. It's not really, really complex. And I think when you begin doing that, they get comfortable. But guess what? The next day, you're doing it all over again. And that's one of the questions I had is through this um, project that you're doing. What are some end results that you've noticed? That would be my question. Like how you're presenting this math. Like look around. We have math all the way around and stuff. But do you have any write-ups or research on that? I would like to know that. I like to share it with my school district.
Yeah, that's a really good question. I know that we've done this in collaboration with several research groups around the country. There's one called M2C3. I'm going to put this in the chat. It's Mathematical Modeling Community and Cultural Contexts. And they have some great resources online. So if you look up M2C3 math modeling, I think you'll find it. And so it's math modeling, community, and cultural context. And I think those are the researchers that are probably writing up this type of task from a research lens. My lens is more experiential with teachers and their students. I feel like for the students, going back to the kindergarten class, the teacher allowed the students to shout out, "Booyah, I see the math," anytime they saw math come up in class. And so in the beginning, she said it was nonsensical, like they were just shouting booyah all the time. But after a while, if she was reading a story and in the story there was a shape like a triangle, and a lot of what they're doing in kindergarten is trying to help kids identify colors and shapes and counting and things like that, the kids would be like, booyah, I see the math. And she'd be like, yeah, where do you see the math? And they'd be like, that's a triangle. And they were using the language and they were able to, again, be excited to point things out. So that's at a very elementary level. I think at, going all the way up to the college level, when I had students do a project like this that sort of began with the question, what do you care about? We had student teams doing things like one of the students had Lyme disease. So they did a whole project on understanding Lyme disease and predicting what was going on with tick populations. We had another one that was concerned about California wildfires, so that they did a team project about wildfire spreading and prevention. We had some that were worried that they had a cafeteria and the lines were too long. And so they did a whole project about how you would look at the lines in the cafeteria to make things work better. Other kids were concerned about water usage. But again, these weren't things I suggested. It was really, but then I gave them the math tools. So this was a differential equations class, and we had done a certain kind of model called a compartment model. And I said, I don't care what you're modeling, you have to use a compartment model. And so the other thing you can do is say, everything is a line, right? And so we have to fit a linear function to any kind of data. But then you have to tell me if it's good or not, right? So you could have something that they're modeling like throwing a ball, and then they could try to model that with lines, and maybe they'll be like, okay, there's a line here and a line here and a line there, but I can't do it with just one line because it's really a parabola. And then you talk about how do you describe mathematically how bad that is to try to fit one line to a parabola, because I think a lot of times we forget that it's as important to do the wrong thing and be able to say why it's wrong as to do the right thing. And in their jobs, right, they're going to have to model things, and the answer's not going to, no one's ever going to have done it before. And so they're going to have to try something. And then when they try it, they're either going to decide it's good enough and useful or it's not. So again, thinking about how to get students to do some work with data and with thinking about things and justifying whether it's a good model or a bad model is great. And with these students, back to my differential equation students, I told them I didn't care whether their model was excellent or terrible as long as they could tell me why. So they tried several things, and they were like, we tried this thing, and then we tried to add this complexity, but it made it worse. And then we tried this and it made it a little better. And so the presentations were so interesting because they weren't just about things that were obvious and easy and worked out great, but they were also about struggles and failures and sort of trying again and trying something different or recognizing when things go wrong. And so I think that's another thing to think about with your students, is that it's as important to be able to recognize when something's going off the rails and pull it back and try something different and persist, like those qualities are at least as important as following a process you already know is going to work and getting an answer that you are pretty sure is already the right answer and then just checking it. So those are more anecdotal, Priscilla, but I absolutely, if you can't find M2C3, you'll have my contact information. I can connect you. They are wonderful people and collaborators, and they just did a presentation for the California teachers that I work with recently. So you could even, if you haven't had Julia Aguirre come in and do a presentation, I think she would be she would probably do things like this. So you could tell her you've already played what do you notice, what do you wonder, but you could ask her a little bit more about some of the data from their research.
I will post that link on the web page. I'm sharing a website here, if I may. This one thing that, so one link that I just added, this is our the website for this workshop, is the NCTM Notice and Wonder page, which talks about the theoretical underpinnings. But in practice, how do you run it? And to my mind, one of the best resources out there that's just amazing is Dan Meyer's 3-acts. And so I want to show this, and I want to show this kind of the way he does. So,
well, David, can I stop you for a minute?
Yeah.
So I would love to focus on that a little bit, but I'd actually like to stay away from that today, if that's okay, and allow people just to look at that another time. So just in a nutshell, raise your hand if you, well, or give me some sign if you've heard of 3-act tasks before. Okay. So there's some familiarity. So 3-act tasks are wonderful because they're data-driven tasks. They basically are closed at the beginning. There's a problem that's posed that's the same problem to everybody. So the students don't define the problem. Then the students can solve the problem any way they want. So they're very open in the middle, but then they're closed at the end again because there usually is an answer, and the answer is presented through a video. So one of the wonderful, and I'm glad you brought it up, David, and Dan Meyer he's a great person to talk to as well if he hasn't come shared with you. So you actually should probably come have him do a presentation for you. He also is involved with Desmos. If you know, Desmos is a free online software and graphing calculator. So he works for Desmos now. But one of the things I really want to say about 3-act tasks is there's sort of a stepping stone to what I'm talking about, because again, they tend to be open in the middle, but they're closed at the beginning and closed at the end. And in the workplace, it's going to be open in the beginning. And so I think 3-act tasks are a great stepping stone and something fabulous if you haven't exposed your students to them. But I want to push you a little bit further to get your students involved in posing the original problem themselves, because I think that encouraging that curiosity and that ability to pose a problem is what we need in our workforce, and something we're really lacking right now. I think sometimes in people's ability to look around at a situation and even know where to start. People often feel overwhelmed when they first start modeling because they're like, I don't even know what to ask. But as you saw with the horses, if it's a context that you know about and you care about, you can ask questions. And then you can start saying, okay, what tools can I use? You can practice that also in 3-act tasks. And then at the end, both allow a student to explain their own idea. But again, there's not always a right answer and a wrong answer to these modeling tasks. And I think that's really freeing, because again, we're getting away from that I got it right or I got it wrong, red X kind of thing, and more like closer to the arts, where we can find value in what every student does. And even if something doesn't work out, there's something to benefit from the thinking or the reasoning or like how they got there. So thank you very much, David. Sorry to interrupt you, but I want to save time because we've only got about 20 minutes left to do one more thing, if that's okay. Is that okay, David?
Yeah. I mean,
okay, thank you so much. Thank you so much.
Let me quickly make some points. As my understanding of 3-acts, one of the things to do is just post a visual image, it reminded me of your horse, and then be quiet and wait until you get at least 3 or 4 mathematical questions. You don't have to follow the full 3-act script. In fact, it's better to answer the questions that the students come up with if you could guess ahead to try to have answers, lovely. But that gives you at least a starting point. He has a spreadsheet with
Lots of great videos
that are searchable. So if somebody said basketball is why I pulled up that one. Somebody else said skateboarding. You can enter skateboarding in the search and you'll find images that already are clear, have math questions that are kind of hinted at, but people can ask other ones. So you don't have to worry about finding the internet. It's a place to.
Yeah, I love that. Thank you. I think it's a great place to start. I also just think that if the student brings the picture, if it's their picture, like everything that's easy for you to have belong to the students gives them that ownership. They're the mathematician, right? They're the problem poser. So I'm really going to push you in that direction for as much as you can. When you can, make the math come from the students, right? It should come from them. It should belong to them. It should be their world. And so thanks for that. So I'm gonna go. Yeah.
One final thing. Somebody else said video games, and so if you're not familiar with Scratch, this is a rudimentary programming, and it has some things that you could follow with just sort of instructions, but students can build their own video games and they need to develop the math and the computer skills to do it. It's designed for kids ages, K through 12. Now,
have you had someone come talk about Scratch with you? Because I also know somebody who's an amazing computer science educator who would love to come talk with you all about Scratch if you ever want them to do that.
We have not done that. We tend to be more math, but I just wanted to point out those resources.
Yeah, so if anybody wants to connect to some computer science education stuff, I'm happy to find you somebody to talk about that too. So thank you so much, David. Those are great additions. All right, so we're going to go back to this slide. Is everybody seeing this okay? Okay, great. All right. So one thing you can do is think about how you might have your students collect their own data for a day. Has anyone ever done this? Again, this can come from questions that your students are interested in, things that they care about. Somebody mentioned earlier sleep. So you could ask, how much do you sleep, right? How regular is your sleep? What are some other things we could ask about sleep? There are actually some apps that track like how disrupted is your sleep, right? You could ask how much does a class sleep on average? Like what's the variation in sleep patterns in the class? Like what's the variation in the times that people in the class go to sleep? Like does everybody go to sleep at different times but wake up at different times, or do they all go to sleep at different times and wake up at the same time? So there's lots of information just about that topic of sleep. I know there was a student who did data for a day that was curious about like how much water they drink in a week. And there's some students that are like interested in their own exercise patterns or strength patterns, those kinds of things. So again, we can build on the fact that sometimes teenagers are very self-focused. And so sometimes they can get more interested in data that's, like I said, personal. It belongs to them. It's actually their data. And, if you can have them sort of pose some questions like, let's study yourself. Like, what can you learn about yourself in a week? You can look online. There's some resources at Joe Bowler's site that I put up there, YouCubed. But this gives them opportunities to collect data, to think about how to share that data with others by using, they could use a spreadsheet with just Excel spreadsheet tools or some sort of open source spreadsheet tool. They could try to use something fancier to do the data visualization. You can use crayons and paper, right? You can create any visualization you want. Then interpreting those data and communicating what they learned about themselves. So it could be data for a day, data for a week, data for a month, but again, helping them realize that the devices that they carry around, or even just the questions that they're curious about themselves. It might even be interesting to ask them, like, what are all the different ways you can collect your own data, right? So if you're talking about how much you drink, is that about time? Is it about volume? Is it about, right? Is it about frequency? Is it about rate? Like, how fast do you drink? Like, how long does it take each person in the class to drink this certain amount? Or how long, you know, what is actually your drinking rate? So again, I'm always trying to think how to get from a quantity, like I drink a gallon, to I drink a gallon per day, or I drink a quart per day, or I drink a liter per day, that kind of thing. And again, that will help them across their chemistry, biology kinds of courses as well. The last thing I wanted to share with you is a task that some friends of mine invented. So this is from Karen Bliss and Ben Galuzzo and Katie Kavanaugh, and they've been running that math competition. Remember, I told you the long-term dream for you all is to get your high school students involved in this math modeling competition. These are my friends who actually create that competition. And they came up with a task that actually came from Arizona. So there was an Arizona sort of Humane Society, I think it was, group that said one pair of unspayed or unneutered cats and their offspring can produce 42,000 cats in just 7 years. What do you think? Do you believe it? So my mind is sort of like, that sounds like a lot of cats. So yeah, I believe it. But then you kind of just like get into the math of it and like, well, how do you actually get that number? So in math modeling, this is called an inverse problem. You have the answer, but you have no idea how someone got it. And so you're trying to do the inverse of the problem and say, you're making this claim. Do I believe this claim? If I use my own methods to try to, so one thing you could do is think about this number. So, you know, here's some examples of lots of different attempts to get that number in different ways. But one thing I'm wondering, so I'm gonna look at our time. How are we doing on time? We have 15 minutes?
You could take another 20.
Well, I'm wondering, could we go into 2 breakout rooms, just divide everybody into 2 different breakout rooms and just think about this problem a little bit and how you would approach it. Now, notice I'm not helping you. I'm not giving you any information about how to solve the problem. I'm not telling you what kinds of math you can use on the problem. I'm also not telling you can't look at the internet, because in the real life, the internet is there. So if you want to do some web searches to try to understand the answer to this problem, and you're willing to tell us what you found and why it makes you believe or not believe this claim, that's great. I'm also not telling you sort of what assumptions to make, right? So there's definitely, like, there's some things to think about here in terms of how you would get your answer. So David, can we just split into 2 breakout rooms, and maybe you can go in one and I can go in the other, and we can play around with this for 5 or 10 minutes, and maybe you and I can chat to each other and let each other know if we're getting somewhere.
Sure, I will set it up for 10 minutes.
Perfect. And this is our last activity. So before you join, you might want to grab just the number 420,000 cats in 7 years.
Hello, I am here. I will serve as note taker, but I want other people to tell me what to write. I'm opening up a notepad to write on and sharing.
Okay. 42,000 in 7 years, huh?
Was it 42,000 or 420?
420,000.
420,000 and another zero. Holy mackerel.
Starting with how many cats?
2?
2.
What was it? 2
Or-
unspayed cats? Just 2. Holy mackerel. Well, definitely an exponential problem.
Yeah, I would say too.
Let me see.
It depends on their litter size too, I think.
Uh-huh.
Yeah, of course, right. Of course. Well, maybe
What about frequency?
Yeah,
letter
frequency.
size, frequency. Sure. Well, the literacy size, we would probably have to come up with like an average,
Mhm.
because I know I've had cats with 1 up to many. I don't even know how many. Would we use probably an average and a litter size?
I'm seeing 3 litters per year,
3 litters per year.
about a total of 12 kittens per year, just based on Google.
Right.
So that means that if you start out with 2 cats, after 1 year, how many do they turn into?
$14.
Uh-huh. So what are we
14, huh?
multiplying by every year? Or what percentage of it increase by? So is this add 12 each year?
Right.
What other operation? So what is the difference? You know, this comes down to what is an exponential model? What do you do in a linear model? What do you do in an exponential model?
Now, if we, at the end of a year, we end up with 14 cats, right?
Yes.
From 2 cats become 14, then wouldn't we probably be talking about 7 pairs of cats?
Uh-huh.
We're doing the same multiplication.
Yes.
Inbreeding?
Yeah, well,
Uh,
that's gonna be happening anyway. Yeah, there's gonna be quite a bit of inbreeding.
So then how many would you have? So, you know, maybe a table of data. Now, 1 year, 2 years, 3 years, 4 years.
Right.
Now there's 2, now there's 14.
So let's,
So what do we get here?
tabular 14. then that's going to be
The expression, not the math, is easier.
right. Let me see.
14 times 7.
7 times 14, 98.
Sure. I actually like this answer better, 2 times 7. And then
Okay.
times
Okay.
7 times 7. Do you see how not
Right,
doing the
exactly.
math
Good.
really makes it
Yeah.
easier?
2 7 to the power of n minus 1.
Well,
Or
what is
n.
n? So it's
Excuse
still
me?
in another
N?
number. 3, what do you get?
Right, okay. Yeah, exactly. 2 times 7 to the 3rd.
Awesome. In fact, humans are much better with numbers. You're on a cusp where you're getting people from doing numbers to algebra. I always recommend that teachers have students work first with small numbers, then medium-sized numbers, and then larger numbers before they do variables. 17 is a good placeholder for a number. Of course, now I think you see it. What is it after n years?
Right.
So what should we plug in here?
Mr. David,
Yes.
could it be 2 times 7 to the n?
I think so. And so, for instance, if we wanted to figure out 7, we'd need to do 2 times 7 to the 7th power. We can figure that out.
Exactly. That's what I got.
So do we think that this number is going to be bigger or smaller than the 420,000 that they got? Any guess before we type it into a calculator window?
I already put it into the calculator.
So people who haven't plugged it in yet, what do you think?
Yeah.
Bigger or smaller? So partly this depends on whether the person is taking other factors into account other than the simple rate. Like inbreeding might slow things down.
Sure.
The size of the environment might slow things down. And so,
True.
So here we're getting 1.
Right. That's what I got.
So we've got 4 times as big as the person
4 times, yeah.
modeling this, right? And so
Bingo.
1.6 million.
It's pretty amazing.
So how do you suppose they made their number smaller? Do you think they just assumed that it was less than 12 new kittens a year? Did they just say 3 new kittens a year? Would that make the right change? Do you think that they had some feature about inbreeding or about maybe it's not an exponential model? How could you include things like that?
I think all of those things would come into play when you would, if you work it backwards, and determine, a different.
Maybe
number.
if you put in the death rate of the kitten.
Yeah, there you go.
Because when you're doing population, there's always the death rate included.
Yeah.
I love it, yes. And what is the death
rate? And death rate and also the fact of overcrowding. There's going to be not enough food at one point,
Yeah.
Yeah, the death rate for sure.
Let me quickly, since we're coming close to 10 minutes, in mathematically, two of the things that we have the notion of two different types of models. We all kind of gravitated towards an exponential model. I think seeing two go to this made us instantly think exponential, which is a very, very reasonable thing to do. In exponential, you multiply by the same number each step.
Right.
In linear, you add the same number. These are some of the most basic mathematical operations we have. It's just addition and multiplication, and thinking when is it appropriate to add versus when is it appropriate to multiply. The reason it was appropriate to multiply was that you had two cats who had babies. If it was only those two cats that had babies,
right,
their babies could not reproduce anything, then they'd produce 12 babies, they'd produce another 12 babies, they'd produce another 12 babies. But what kicks in is you produce 12 babies who then each pair can produce 12 new babies. And this is why things are lining up.
Given that half and half are female male.
Yeah, and so is it the balance? Let me just comment that we're not going to have time, I think, to make the model much bigger, but one type of model that you get here is what's called a recursive model.
Okay.
How many people have heard of recursive functions or a recursive model before?
I've heard of it. Not very.
Fibonacci.
Can you say what a recursive means or how we're describing it?
You use previous numbers to calculate the next one.
Yes, that's a great description.
Yeah, thank you. Use previous numbers to calculate them. Sure.
So my handwriting on a computer screen is pretty hideous and ugly, but
you're not alone.
We're used to this. So for instance, with the number of cats, we could talk about the number of cats in year in plus 1 was equal to 7 times the number of cats in year in. This included the fact that cats produced more cats. But this is just the birth rate. If you were going to add something like the death rate, what might you add in order to get a death rate? Or how could you adapt this? So is the death rate always going to be 2 cats per year die? Is that a good model?
No, that's going to increase as well.
And how is it going to increase linearly, quadratically, or exponentially in the number of cats?
Exponentially.
So
I would think.
So it seems like it might be, so there's two different things. There's the change in the number of cats versus the number of cats. Over here, this is a linear function when I'm looking at the change of the number of cats, which leads to an exponential growth in the number of cats. If we did something like minus C sub n, because if you have 100 cats, if you have 10 cats, a certain number of cats die per year. If you have 100 cats, it's natural to expect that 10 times more cats would die per year.
Okay.
And so that's the reason why, if 10 cats give you 2 cats die per year, then 100 cats would give you 20 cats.
Yeah, right.
And so this I was using based on a model of death.
Right.
So this would be 5 times Cn. You could put more complicated things, like one thing that you might have is you might have a birth rate minus a death rate. times the number of cats. But then you might have something like size of the environment. You know,
because that's not going to be
minus
ever
the number of
expanding.
cats. Because a term like this that you added would say if there's only enough rats that could feed the cats, right? We could talk about food per cat. That's going to cut this thing off. I think maybe I'll do this multiplication and then close the window. Just spitballing death rate. So, you know, it looks like they're getting a rate birth minus death that's between 7 and 5. Maybe they took 6 because they got the birth rate and then said 1 cat dies per year on average. It's hard to say, but that gives some thoughts. Let me see if I can get to the breakout rooms. Where are the breakout rooms? Somebody remember where I might have hidden those in here?
Sure do.
Pause sharing annotate. I'm gonna stop. Maybe that'll get me my controls back. Reactions, more. Somebody know where the breakout rooms are? Here we go. I'm going to close the rooms now.
Yep.
Welcome back. How'd y'all do? Did you have some fun? So who was it that was just talking about, I'm looking for who was talking about the rabbits. Was that Al?
Yeah, that's me.
Al, would you feel comfortable just, so David, we had some fun and we made some assumptions and came to a conclusion, and maybe Al, you can describe that. And then we'd love to hear just in a minute or two what you all came up with.
The first
And when I say we, I don't mean me. I didn't do any of the work. I don't claim any. I didn't help at all.
Priscilla first mentioned that she thought that a litter of cats would have 8 kittens and that they would have kittens 3 times a year, so every 4 months. But then we decided that maybe having 8 kittens would be a little too difficult to deal with. So we changed to thinking about a litter of cats only having 2 kittens, which then I thought that was very similar to the Fibonacci rabbit problem, where one pair of rabbits makes another pair of rabbits every month, and then it takes a month for the rabbits to grow up and a month to gestate the new rabbits. And so I just like looked for the 28th Fibonacci number. So if you follow that cycle, but instead of every month, you do every 3 months, you could do the 28th Fibonacci number is 317,000. So we're within 100,000 of the 420,000 number. And that's assuming like a much smaller litter size. So.
Thanks. And this brings up a really other wonderful thing about modeling, which is I feel like in textbooks, the answers are always like a particular number and not like plus or minus 100,000. So it also always brings up the question, like when you're modeling, how close is really close? And again, this will relate very nicely to chemistry and biology and physics, where you tend to have data that come from experiments that have error in them and are more messy and, you know, have assumptions in them that may not be the same from person to person. So some really nice connections there. And Al, thanks for incorporating a lot of the different suggestions that came from different members of the group and then kind of carrying it a little bit further. David, is there someone from your group that might be able to report out just what you tried, even if you didn't come up with a number or a conclusion?
Yeah, I hope somebody will volunteer.
did you have anything that you struggled with that you kind of, like, we had some things that people said that were like, well, I thought I might do this, but then I realized it didn't work.
I think Anna would report out really good.
Thanks, Marty.
You're welcome.
I was looking for the other David. We did a Google search to see how many cats litters, I think similar to what you did. And we started with 12 having 12 cats per year. And the other David kind of led to the, well, if they have 12, that leaves 14 cats in a year. And then each of those 14, like, we'd have 7 pairs. And so we used that to calculate in 7 years, there'd be over 1 million cats. And so then we're like, that doesn't seem right.
And maybe it is.
So somebody else brought up the death rate and other environmental factors. And like, I mean, is it really 12 per year? Or, and then there's the inbreeding. And so we talked about it being exponentially increasing. Somebody mentioned the Fibonacci too. So
nice. Thank you so much. I hope that it, oh, go ahead.
I wanted to add too that we got close to the amount as well too, to include the death rate of the cats. And so we got within the amount calculated.
You got a closer number.
Yeah, because in population, we always have to include the death rate. So that's part of our answer in that word problem.
Yeah. And it's funny too, our tendency to like decide that this number is the right answer, even though it could be totally wrong, right? You know, I felt the same way. Like, as I was trying to work this problem for myself, I kept thinking, well, can I go on the internet and find the right answer so that I can get the right answer? But the point is that it will depend on what assumptions you make. What the answer is going to be. And this number, you know, I think it's a good question, like whether this is a sensible number, but it could be a totally wrong number.
And I think that's what our students, you know, think the same way too. They want to get the right answer. But if you know, say, you know, there's no real actual answer, then they go with it. You know,
that's good to hear.
Yeah.
Hear that. Well, David, I don't want to take too much time. I just want to leave you with this thought that this is all about putting mathematical tools in your pockets and learning how to choose the ones that you need and use them appropriately so that you build the power to solve problems that haven't been solved before. And that's really what our employers need, what our world needs. And I really believe that your students can attain both of these goals. So I know your students can go out and begin to recognize math in the world all around them. And I know that in the future, at some point, you all can stand up a team for the M3 Mathworks Math Modeling Challenge, and I will do anything you need me to do to help you get there. So if any of you, you know, I will be available to you in the future. Here's my email. You can email me anytime about anything about math modeling that you want to talk about or math in general. And I would be very happy. I have done this at every workshop I've ever given, and I usually do hear from a teacher afterwards. And we have sometimes, you know, one time it was a teacher in Kentucky, and she was just like, I just need to talk to you about my students and my class and what their biggest problems were. And they had some really serious biggest problems. I mean, she said, you know, 80% of my students, their folks are in jail. What do we do? And I said, you know, what are the problems around that? And we really did think a little bit about some math modeling the students could do around, you know, visiting hours and things like that, that were important to them around that issue that was really impacting their lives in a way that she felt like was coming into the classroom every day, but she didn't have a way to connect it with her curriculum. And so, you know, I am really excited to hear more about skateboarding and horses and video games and food and the things that your students really care about. You know, and Anna, I want to thank you again so much for the conversation that we had before this, just so that I could have a little more sense of the context of your students and their lives and their classrooms. And I hope this was useful and fun and a good use of your time at the end of a very difficult year. It's been a pleasure and an honor to work with you.